Welcome to qnawire.
So I see that you need help with this question. And so it says the director of the alumni association wants to determine whether there is a type of relationship between the amount of alumni's contribution in dollars and the number of years the alumni has been out of school. Based on the data below, compute the standard of error of the estimate for the relationship between the number of years and the amount of the contribution. Okay, so in order to answer this, you first have to find this your SSE number. That's the sum of your products. And I'm sorry, the sum of the squares of y. So what you have to do is you have to find the difference between your y value and your mean of y. And then you square each one of those values, add them together, and you get your SSE. And so then to get your mean square error, you're going to take this 53,872.9 and you're going to divide it by the amount of numbers that are here. So 1, 2, 3, 4, 5, 6 minus 2. So that's 53872.9 divided by 4. And so your mean squared error, your MSE, is 13,468.22. And that would be this value, C. And, so that's your mean squared. And then your standard of error, you're going to take this number and you're going to find the square root of it. So let me fix this. So it's going to be this, A. So finding the square root of that, then it's going to be A. The total body cholesterol concentrations in mg/dl are shown below for a random sample of 6 people. In the table below, R is the age of the subject and Y is the subject's total cholesterol concentration. Find the 95% prediction interval when X equals 52. So we have the ages of 31, 42, 52, 67, 66, 76, and then we have 183, 214, 239, 239, 266, 224, 253. And then taking a look at your confidence interval, and so it says for the 95% confidence interval, when X equals 52, so X is going to equal 52, it is going to be anywhere between, let's see, anywhere between C. So let me just make sure, just double checking my math. And then for this one, a random group of seniors was selected from a university and asked about their plans for the following year. The school advertising office claims that 50% of the students plan to work, 30% of the students plan to continue in school, and 20% of the students plan to take some time off. Is there evidence to reject the hypothesis at A equals 0.05? So we have plans and then the number of students. So there is evidence to reject the claim because, and then it gives each one of these, whether it's going to reject the claim or confirm the claim. Okay, so 19 plus 14 plus 8, that equals 41. And for the work, 19 out of 41 is 46%. 14 out of 41 is 34%. And then 8 out of 41 is 20%. And if we are going to say, so we're going to find the difference in the means and difference between them. And we're going to do raw data. So we're going to do 0.5, 0.3, and 0.2. And we're going to do matched pairs, 0.46, 0.34, and 0.2. And it's a 95% confidence interval. And so anywhere between, so the answer here is going to, we are going to reject the claim that the students' plans are distributed as claimed because the test value is 0.35, which is less than 5.991. So I hope that this video helps. This is middle school math teacher signing out.